What is the true size of the universe, and how did humans first dare to measure it? Long before telescopes pierced the night sky, ancient civilizations lifted their gaze and filled the heavens with stories. To the Babylonians, the cosmos was a divine dome arching above a flat earth. To the sages of Vedic India, creation unfolded in endless cycles. A rhythm of birth and dissolution, stretching far beyond human comprehension. The Greeks, too, wrestled with the question. Aristotle imagined perfect crystalline spheres, finite and ordered, enclosing the planets and stars. Yet Democritus whispered of a darker possibility, a universe unbounded, an infinite sea of atoms, drifting in an endless void. Infinity unsettled the human mind. It was not a comforting thought. It was terrifying. How could fragile beings endure the idea of a cosmos without edge or boundary? And yet curiosity pushed them forward. Eratosthenes, in the 3rd century BCE, lowered a measuring stick into the shadow of the sun and used geometry to weigh the very size of Earth. Centuries later, Copernicus dared to move our world from the center. Placing it among planets circling a star, each step was an unraveling. Each discovery pulled away a layer of myth, revealing a cosmos stranger and grander than the stories told around ancient fires. When Galileo lifted a simple telescope, the night erupted with countless stars, moons circling Jupiter, and visions that no myth had ever drawn. The universe was no longer a canvas for gods. It had become a question written in light, and humanity had only just begun to answer. The night sky has always been a mirror for human longing. For millennia, it appeared unchanging, a vault of lights burning with eternal patience. Yet in the early 17th century, a simple tube of glass changed everything. When Galileo Galilei lifted his handmade telescope toward the heavens, the universe began to multiply before human eyes. Through the lens, stars did not remain solitary points. They swelled into multitudes, shimmering in clusters beyond counting. The Milky Way, once thought to be a pale band of mist, resolved into an ocean of stars so dense it seemed endless. Moons circled Jupiter in silent procession, proving that Earth was not the sole stage upon which celestial bodies performed their dance. The heavens were no longer a pristine clockwork of perfection. They were alive with motion, diversity, and chaos. What Galileo revealed was more than an expansion of sight. It was an expansion of imagination. Humanity stood at the threshold of an infinite stage, and the stories told for generations could no longer contain the truth. The cosmos was not fixed. It was vast, restless, and filled with surprises that defied the boundaries of ancient thought. In the centuries that followed, curiosity demanded greater instruments. Larger mirrors, longer tubes, more sensitive lenses. Each one peeled back another layer of mystery. Among the pioneers stood William Herschel, a musician turned astronomer whose hunger for the stars consumed his life. With telescopes of his own design, Herschel mapped the Milky Way, charting star after star with relentless patience. He believed he was outlining the very structure of the universe itself. To him, the galaxy was not merely a scattering of lights, but an organized system, an island cosmos suspended in the dark. For the first time, humanity began to glimpse structure within the abyss. Yet the revelation carried a paradox. The more Herschel measured, the more the universe refused to be contained. His maps revealed that the Milky Way stretched farther than anyone had dreamed, and still it hinted at depths beyond his reach. He sketched what he thought was the edge, but the edge dissolved with every improvement in his instruments. The universe seemed determined to stay larger than the human mind could grasp. This new vision struck at the core of philosophy. Once, the heavens had been imagined as closed, finite, an ordered dome arching above a central Earth. Now, they opened into endless stellar fields, stretching into darkness without end. The terror of infinity returned, no longer a whisper from philosophers like Democritus, but a fact etched into the sky with glass and light. Every discovery dissolved boundaries rather than confirming them. Where once people sought to locate themselves at the center of creation, they now faced the possibility that there was no center at all. The universe was not a sphere enclosing humanity. It was an abyss in which Earth drifted like a leaf upon an ocean. And yet this abyss was not empty. It was filled with suns, each one a possible world maker. Galileo's moons, Herschel's maps, and the countless stars revealed by their instruments were not just curiosities. They were an invitation. Each observation whispered that the human story was not confined to Earth. The cosmos was wider, richer, and more alive than myth had dared to describe. But with every layer revealed, the questions grew sharper. If the Milky Way was an island, could there be other islands beyond? If stars were not eternal but burning fires, what awaited when their fuel was spent? Was infinity not only real but populated, stretching endlessly in ways the mind could not yet conceive? The telescope became more than a tool. It became a symbol of defiance against the darkness. A fragile cylinder of glass and metal, wielded by hands of flesh, capable of pulling light across impossible distances. It stood as proof that human beings, though bound to a single planet, possessed the will to see farther than their place would. Suggest that Galileo paid a heavy price for his revelations. Herschel sacrificed years to cold nights and unending calculations. Yet their legacy was not just scientific, it was emotional. It reshaped what it meant to be human beneath the stars. To look through their instruments was to feel both small and immense at once. Small, because Earth was no longer the center. Immense, because the human mind could imagine and measure what lay beyond, in the silence of the night sky. Humanity discovered that knowledge does not comfort. It unsettles. It pulls away the walls that once seemed secure. The more the universe revealed, the less it resembled a home designed for us. Instead, it appeared as an unfolding wilderness, ancient and indifferent, yet profoundly beautiful. The first windows beyond Earth were narrow, but they changed everything. They shattered the dome of the heavens and replaced it with a horizon that could never be reached. What began with a telescope of wood and glass ignited a chain of discovery that still burns today. The act of looking outward became inseparable from the act of questioning inward. In that moment, humanity stepped into a new relationship with the cosmos, no longer sheltered by myth, no longer bound by illusion, but carried forward by curiosity. Into a universe that promised wonder and dread in equal measure, the stars had multiplied, and with them, so had the mysteries. In the early 20th century, the telescope had grown into a giant. No longer the fragile tubes of Galileo and Herschel, but steel and glass behemoths raised on mountaintops. Capturing light with mirrors so vast they seemed to drink the night itself. It was through such an instrument, perched at the Mount Wilson Observatory in California, that Edwin Hubble made one of the most profound discoveries in the history of thought. The universe, it turned out, was not what it seemed. For centuries, the Milky Way had been assumed to be the whole of creation. Even Herschel, with all his maps, believed that the faint smudges scattered across the sky might simply be clusters of stars within our galaxy. But when Hubble examined the Andromeda Nebula through the 100-inch Hooker telescope, he uncovered something astonishing. That dim spiral of light was not a cloud within the Milky Way. It was a galaxy in its own right. Out city of stars, hundreds of billions strong, dwelling far beyond the borders of our own. Andromeda was not alone. One by one, the fuzzy smudges resolved into galaxies, each one a colossal island of suns, drifting across a vast ocean of space. The universe multiplied in scale by orders of magnitude. What had seemed immense became, in an instant, provincial. The Milky Way was no longer the universe. It was a single shore in an archipelago without end. But Hubble's revelation did not end with the discovery of other galaxies. He noticed something more unsettling. The light of these galaxies carried secrets within their spectra. The familiar fingerprints of hydrogen and helium were shifted. Their lines stretched toward the red end of the spectrum. The farther away a galaxy lay, the more its light was stretched. The conclusion was inescapable. Space itself was expanding. This was not motion in the ordinary sense. Galaxies were not flying through a pre-existing void. Instead, the void itself was swelling, carrying galaxies apart like leaves adrift on a rising tide. The universe was not static, as Aristotle and Newton had once imagined. It was dynamic, restless, unfolding in time. Hubble had revealed that the cosmos itself had a history. If the universe was expanding today, then long ago it must have been smaller, denser, hotter. Run the clock backward, and all the galaxies draw closer, converging into a single point. From this insight, the idea of a cosmic beginning took form, what we now call the Big Bang. For the first time, humanity understood that the cosmos was not eternal in its present state. It was evolving. And in its evolution lay the fingerprints of origins. The discovery reshaped not only astronomy, but philosophy. Once, infinity had been terrifying because it was empty. Now it was terrifying because it was alive, growing, and filled with countless worlds. Each galaxy, each spiral or elliptical smear of light held hundreds of billions of stars around. Those stars, countless planets. Around those planets, perhaps other stories, other beings staring into their own night skies with the same question. The scale of this revelation defies imagination. The observable universe contains more than 2 trillion galaxies. Each one is a cathedral of stars, stretching across hundreds of thousands of light years. And yet, even this incomprehensible multitude is only what we can see. Beyond the observable lies a darkness forever hidden, light too distant to have reached us in the age of the cosmos. Here, light itself becomes a time machine. To gaze into the sky is not merely to look outward, it is to look backward. The light of Andromeda began its journey more than 2 million years ago, when early humans walked the African plains. The Hubble Space Telescope, peering deeper, captures galaxies as they were billions of years in the past, glowing faintly when the first stars were being born. Every image is a fossil of light, carrying us back toward the dawn of time, but with each triumph of vision comes a deeper humility. The more the universe reveals, the greater the shadow of what remains unseen. The observable universe is defined not by what exists, but by the limits of light and time. Beyond those limits may stretch realms we will never reach, galaxies whose light will never fall upon our instruments, no matter how powerful. The universe expands faster than light can carry their story to us. They are lost to eternity, separated not by distance alone, but by the fabric of time itself. This realization brings both wonder and sorrow. Wonder, because we live in a cosmos of staggering richness, a tapestry woven from trillions of galaxies, each with its own history. Sorrow, because most of that tapestry will remain forever beyond our grasp. Humanity has discovered that it dwells not at the center of the cosmos, but on the edge of what is knowable. And yet, within that edge lies a profound gift. The observable universe is not merely a boundary, it is a window into the deep past. By studying the faintest, most ancient light, astronomers can reconstruct the story of creation itself. They can trace the expansion, measure the echoes of the Big Bang in the faint afterglow of cosmic microwave background radiation, and glimpse the first galaxies assembling out of darkness. The cosmos offers us its autobiography, written not in words but in photons stretched across billions of years. This story humbles us. It teaches that knowledge does not end with answers, but with new questions. If the universe is expanding, what drives that expansion? If galaxies recede from one another, will the cosmos continue to stretch forever, or will gravity one day reverse the tide? If light carries us into the past, what lies in the future, beyond the reach of our instruments? The Great Expansion revealed not a conclusion, but an opening. Humanity, once bound to a single world, now stood before a universe whose scale shattered all previous imaginings. The stars were no longer points upon a dome. They were the fires of galaxies scattered across an abyss, whose size grows with every observation. The more we see, the more we realize how much remains hidden. The Great Expansion does not end with a boundary. It stretches into mystery without horizon. And in that mystery lies the enduring tension of human curiosity, to look outward. is to find beauty beyond measure. To look outward is also to confront the silence of what will never be known. The galaxies drift apart. Their light grows fainter. Yet in that fading glow, humanity finds its most profound reflection. A fragile species bound to a small planet, daring to measure the immeasurable. And so the universe expands, and with it, the human soul. The universe is not an endless canvas open to the naked eye. It is bounded by a limit not of matter or distance, but of time itself. That boundary is called the cosmic horizon. Light, the fastest thing known to physics, sets the rules. Its speed is immense, nearly 300,000 kilometers every second. It is finite. A beam of light can circle Earth 7 times in a single heartbeat, but it cannot cross infinity. When we look into the sky, what we see is shaped by that constraint. Every star, every galaxy, every faint whisper of light has traveled for ages to reach us. To observe the cosmos is to read a history written in photons, each one carrying the story of where it came from. The age of the universe is 13.8 billion years. That number is more than a measure of time. It is a wall against which sight itself collides. Because light can only travel so far and so long, there is a maximum distance, beyond which nothing can be seen. Beyond that boundary, the universe exists, but its light has not had time to reach us. The past has not yet arrived. Yet here lies a paradox. The observable universe does not extend 13.8 billion light-years in radius. Instead, it stretches far larger, about 46 billion light-years in every direction. The reason is cosmic expansion. As light travels, the very fabric of space stretches beneath it. Distances grow while the beam is still on its way, so that the source ends up far beyond where it was when the journey began. What we see is not simply how far light could travel, but how much the universe has grown since it was emitted. This stretching of space means that when we peer across cosmic time, we are not just looking outward, we are looking backward through an expanding stage. The galaxies whose light reaches us from billions of years ago are now much farther away than their light suggests. The observable universe is a sphere of memory, swollen by the relentless growth of space. It is difficult to grasp this paradox of sight. Imagine standing on a shore at dawn. Before you lies a vast ocean, waves vanishing into mist. The horizon is not the end of the sea, only the end of vision. Beyond it lies more water, unseen, unreachable, yet undeniably there. The cosmic horizon is much the same. We live on the shore of the observable universe, able to see only so far, knowing that beyond our sight the ocean of existence continues without end. Astronomers measure this horizon with exquisite care. They use the faint glow of the cosmic microwave background. The afterglow of the Big Bang to trace the farthest edge of visibility. That light began its journey just 380,000 years after the universe was born. The cosmos became transparent. Everything before that moment is hidden, locked behind a veil of plasma, too dense for light to escape. In that glow, we find the oldest message we will ever receive. Beyond it lies silence. The horizon is not a fixed boundary. With every passing second, light from new regions arrives, pushing the edge of the visible farther outward. Yet cosmic expansion plays a cruel trick. Some galaxies recede faster than light itself, because space between us grows at a rate unconstrained. By the rules of relativity, their light will never reach us. They slip over the horizon, carried away into a night we will never touch. This creates a universe both generous and withholding. Generous because it grants us glimpses across billions of years, allowing us to witness galaxies forming when the cosmos was young. Withholding because it denies us the whole picture, forever keeping part of its story veiled in distance and time. The horizon is a reminder that knowledge comes with limits. No matter how powerful our telescopes become, no matter how deep into space we stare, there will always be a curtain drawn across the ultimate stage. What lies beyond remains speculation. Perhaps the universe stretches on infinitely. Perhaps it curves back upon itself in ways we cannot perceive. Perhaps it harbors realms utterly unlike our own. But none of it will ever be confirmed by light, for light cannot reach us from those depths. And yet, within these limits lies meaning. The cosmic horizon is not a wall, but a perspective. It teaches that to see is not to know everything, but to know enough to wonder. It reminds us that we inhabit a fragment of a story too vast to be contained in any single view. Standing beneath the night sky, humanity is like a figure at the edge of a great ocean. The waves we see are the waves that have arrived. Beyond them lies water stretching farther than the eye, farther than the mind, farther than imagination itself. We cannot sail it, cannot measure its end. We can stand on the shore, aware of its immensity and feel the pull of its mystery. The cosmic horizon is both boundary and invitation. It whispers that there is more beyond reach, more beyond sight, more beyond understanding. It is the line where knowledge ends and wonder begins. And at that line, humanity looks outward, humbled and exalted all at once. The story of the universe begins not in silence, but in an eruption. The Big Bang marked the dawn of space and time, yet even that picture holds a secret more astonishing than the explosion itself. In the early 1980s, physicist Alan Guth proposed a theory that reshaped the beginning of everything. He called it cosmic inflation. According to this idea, the newborn universe did not expand gently. It surged. In less than a trillionth of a second, space ballooned by an incomprehensible factor. Regions smaller than the nucleus of an atom stretched into scales larger than the observable cosmos. It was not a burst into pre-existing emptiness. It was space itself erupting. Doubling again and again with exponential fury, this moment of inflation explains mysteries that had haunted cosmologists for decades. Why is the universe so uniform in all directions, when distant regions have never had time to exchange light or heat? Why is space so perfectly flat, balanced on a knife's edge between eternal expansion and eventual collapse? Inflation provides the answer. It's that brief, furious swelling smoothed the cosmos, ironing out wrinkles, diluting irregularities, making the stage for galaxies to form from tiny ripples in density. Yet the implications reach far beyond elegance. If inflation happened once, it may never truly have stopped. In some models, space continues to inflate eternally, birthing new regions of cosmos like bubbles on a boiling surface. Our observable universe would then be one bubble among countless others, each with its own galaxies, its own physics, perhaps, even its own laws of nature. What once belonged to philosophers as speculation, infinite cosmos, suddenly stepped into the realm of mathematics and physics. This realization carried a shock. Infinity was no longer an abstract word whispered. In metaphysics, it became a scientific possibility, encoded in equations and supported by the afterglow of the Big Bang itself. The faint pattern of cosmic microwave background radiation, mapped by satellites such as COBE, WMAP, and Planck, carries imprints that inflation predicted, a universe flat to extraordinary precision, seeded with tiny fluctuations that grew into galaxies and clusters. The numbers defy comfort. If inflation expanded the cosmos beyond our horizon, then what we see, the 46 billion light-year sphere of the observable universe, is a vanishingly small fragment, like a grain of sand against a desert without end. The true size of the universe may exceed comprehension not by a factor of 10, but by magnitudes without limit. It may be infinite. For scientists, this was both exhilarating and unsettling. Science thrives on testable boundaries, on experiments that confirm or deny. Yet if the universe is vastly larger than we can ever observe, then most of reality is forever beyond our reach. We cannot touch it, cannot measure it, can only infer its presence from the mathematics that govern the patch we see. In this way, the human mind confronts its own limits. The emotional weight of this realization is profound. To speak of infinity is no longer to entertain a thought experiment. It is to stare into a truth that physics itself suggests. Infinity ceases to be poetry. It becomes geometry. It becomes energy. It becomes terrifying. Imagine standing on a high cliff at night, looking out across an ocean that has no horizon, no shore, no edge. The waves stretch into darkness forever. That is the cosmos inflation describes. Not a universe designed to be grasped, but a universe vast beyond reason. A stage so immense that the entire human story, the entire history of stars and galaxies, occupies only a whisper of its expanse. And yet there is wonder in this terror. Inflation implies that the seeds of everything, every star, every planet, every living being were born from quantum fluctuations smaller than atoms. The galaxies overhead trace their ancestry to random tremors in the vacuum, amplified by the universe's earliest heartbeat. Out of that microscopic foam arose the architecture of the cosmos. Out of near nothing came everything. But with that wonder comes humility. If inflation truly occurred, then our universe is not the universe. It is only one observable patch, a bubble adrift in a sea of others. Some may harbor no stars at all. Some may burn with strange forms of matter. May obey laws of physics utterly alien to ours. The multiverse becomes not a fantasy, but a consequence. A possibility etched into the equations that describe the birth of space. This vision unsettles the soul. It denies us the comfort of centrality, denies us the illusion of boundaries. It forces us to accept that our place is not only small in size, but small in meaning. Even the word universe, which once meant everything, no longer holds. If inflation is true, then universe is only local. The totality lies beyond language. Still, the human mind persists. Scientists test inflation not by chasing infinity, but by searching for its fingerprints within reach. They study the polarization of ancient light. They seek the subtle twist of gravitational waves imprinted on the cosmic microwave background. Each piece of evidence brings them closer, not to confirmation of the infinite, but to confidence that inflation left its mark. And so humanity stands in a strange position. It cannot know the whole, yet it can glimpse enough to sense the enormity of what lies beyond. The observable cosmos becomes a window, and through it, one sees only the faintest hint of a greater expanse. Inflation teaches a sobering truth. The universe is not built for human comprehension. Its size, its scope, its endlessness are not designed to be comforting. They are designed by physics, indifferent and vast. Infinity does not care if it frightens. It simply is. And yet, within that immensity, a fragile species dares to ask, to calculate, to wonder, to imagine. Out of fear is born curiosity, and out of curiosity, discovery. The terror of infinity becomes the poetry of science. In the end, inflation does more than explain the cosmos. It transforms the human relationship to reality. It replaces the question of how big with the realization that size itself may be meaningless. It reminds us that to exist, to think, to see even a fragment of this expanse is itself a miracle. Against impossible odds, the universe may be infinite. Our place within it may be no more than a single heartbeat. But in that heartbeat, humanity has glimpsed the unthinkable vastness, and the vastness is enough to change everything. What is the shape of everything? It seems a simple question, yet it reaches into the deepest layers of physics and philosophy. For the universe is not only filled with stars, galaxies, and matter, it is also defined by the geometry of the space that contains them. Albert Einstein's general theory of relativity revealed that space and time are not rigid backdrops but flexible fabrics, bending under the influence of energy and mass. Planets orbit stars not because they are pulled by invisible forces, but because space itself curves, guiding them along its warped contours. If gravity can shape the path of a planet, then what of the universe as a whole? Could the entire cosmos itself possess a shape? Mathematically, three broad possibilities emerge. The universe could be closed, curving back upon itself like the surface of a sphere. It could be open, curving outward like a saddle that stretches without bound. Or it could be flat, balanced between the two, extending straight in every direction. Each option carries profound consequences. A closed universe might one day collapse upon itself in a fiery end. An open one might expand forever into emptiness. A flat cosmos would hang on the delicate edge between, its fate determined by subtler forces. The question is not trivial. It determines not only how far the universe reaches, but whether infinity itself is real. If space is closed, then the cosmos, though vast, is finite, yet unbounded, like a globe whose surface has no edge, yet whose area can be measured. If space is flat or open, the universe could be infinite, stretching without limit, containing unending galaxies in every direction. The search for the universe's shape demanded precision. Astronomers turned to the oldest light, the cosmic microwave background. A relic from 380,000 years after the Big Bang, this faint radiation, spread across the sky, carries tiny fluctuations, ripples in temperature no larger than a few millionths of a degree. By measuring how those ripples appear at different scales, scientists could infer the geometry of space itself. The Wilkinson Microwave Anisotropy Probe, launched in 2001, scanned the heavens for years. Its successor, the Planck satellite, mapped the background with even finer detail. Together, they delivered an answer both precise and unsettling. The universe appears flat, not perfectly flat, but so close that any curvature must be vanishingly small, less than a fraction of a percent. Within the limits of measurement, the cosmos extends in straight lines. This result shook the imagination. A flat universe allows the possibility of infinity. If the geometry continues without curvature, then space has no boundary. Galaxies would extend forever, and the observable universe, vast as it seems, would be only a local patch in a limitless expanse, yet uncertainty remains. Flatness within measurement is not the same as perfect flatness. It could be that the universe is slightly closed or slightly open, with a radius so large that our instruments cannot detect the curve. Just as a person standing on Earth's surface perceives the ground as flat, though it is round, humanity may be too small to perceive the arc of the cosmos. To explain this, cosmologists often turn to the image of a balloon. Imagine ants crawling across its surface. To them, the world appears flat locally, but as they travel, the curvature reveals itself. Likewise, the universe may be finite, yet unbounded, looping back upon itself so that a beam of light, given inconceivable time, could one day return from behind. The analogy is imperfect, for the balloon has a center in higher dimensions, while the universe may not. But it conveys a truth. The shape of space defines the limits of all journeys. And yet, despite the data, mystery endures. Flatness too within. Margins does not end the question. Infinity itself is a concept that unsettles the mind. If the universe is infinite, then every possible arrangement of matter might exist somewhere. Another star like the sun, another Earth like ours, another human gazing at the night sky with the same question. The cosmos becomes not only vast but unthinkably repetitive, stretching into possibilities that strain imagination. If instead the universe is closed, the implications are no less profound. A closed cosmos would mean we dwell within a finite whole, a vast but measurable sphere of existence. It would carry the haunting possibility that expansion is temporary, and that one day gravity could halt the outward rush, drawing everything back into collapse. Galaxies, stars, atoms, even the fabric of space itself, returning to a final singularity. For now, the evidence leans toward flatness, cosmos balanced on the knife's edge of geometry. But certainty eludes us. The margins of error whisper of other possibilities forever hiding in the space between precision and truth. The shape of everything remains unknown. This uncertainty is more than scientific, it is emotional. Humanity stands within the universe asking questions about the very ground of being, yet unable to step outside and see the whole. It is like a traveler wandering through a forest, never able to rise above the canopy, always guessing at the terrain by the slope of the land and the patterns of the trees. The cosmic horizon blinds us to the full picture, leaving us with hints, probabilities, and metaphors. Still, those hints are enough to remind us of our place. Whether infinite or finite, closed or flat, the universe reveals a truth that transcends measurement. It is larger than us in ways both physical and philosophical. The geometry of space is not merely a technical question. It is the architecture of reality itself. To ask about the shape of the universe is to confront the edge of knowledge. To live in that question is to feel both small and exalted. The answer, whatever it may be, will not diminish the mystery. For even if the universe is infinite, the human mind will always find new infinities within it. And so, the question endures, echoing across science and philosophy alike. What is the shape of everything? The data draws us close, but the truth remains just beyond reach. In that distance lies wonder. In that uncertainty lies awe, and in that awe, humanity discovers not the shape of the universe, but the shape of its own curiosity. The universe we see feels impossibly vast. Trillions of galaxies drift across billions of light years, and yet, according to some of the boldest ideas in modern cosmology, this may only be a fragment of a greater whole, beyond the cosmic horizon. Beyond even the reach of imagination lies the possibility of other universes. Together, they form what is called the multiverse. The seed of this idea emerges from the theory of inflation. In Alan Guth's original picture, inflation began and ended quickly, allowing the universe to slow into a more gentle expansion. But in later refinements, physicists discovered something unexpected. Inflation does not stop everywhere at once. Instead, it can continue eternally, with pockets of space ceasing their runaway expansion at different times. Each pocket becomes a bubble, cooling into a universe with its own galaxies, stars, and physics. Meanwhile, the inflating background continues to swell, spawning bubble after bubble without end. Our universe, then, could be one such bubble. Its laws of physics, its particles, its constants, everything that defines its nature may be local rather than universal. In other bubbles, the speed of light could differ. Gravity could be stronger or weaker. Chemistry could follow alien rules. Some universes might be short-lived, collapsing almost as soon as they are born. Others might never form stars at all. And somewhere, perhaps, exist universes with conditions far stranger than anything the human mind can conceive. This vision is breathtaking, but it is also unsettling. For centuries, the word universe meant the totality of existence. To imagine multiple universes is to undo the very meaning of the term. What does it mean to speak of our universe if it is only one among countless others? The multiverse transforms the cosmos from everything into something. It demotes even the grandest scales we know into a local phenomenon. Evidence for this idea is elusive. The multiverse may be forever beyond direct observation. By definition, other universes are outside the horizon of our own, separated by inflating space that expands faster than light can bridge. Yet mathematics whispers of their possibility. The equations of inflation predict eternal growth. Quantum mechanics suggests branching realities, where every possible outcome exists in some version of the whole. String theory, with its higher dimensions and intricate landscapes, offers room for countless solutions, each one corresponding to a different universe with different physical laws. Hints may appear in subtle ways. Some cosmologists have proposed that collisions between universes could leave scars, unusual patterns imprinted on the cosmic microwave background. Others wonder whether the very values of our physical constants hint at the multiverse. For example, the strength of dark energy appears finely tuned to allow galaxies to form. Too strong, and the universe would have expanded too quickly for stars to coalesce. Too weak, and it might have collapsed before life had a chance to emerge. In the multiverse, such fine-tuning ceases to be mysterious. It is simply selection. We exist in this universe because only in such a universe could beings like us exist at all. But this reasoning raises uncomfortable questions. Is the multiverse an explanation, or is it a surrender? If other universes cannot be tested, then do they belong to science or to speculation? Some physicists argue that the idea strays too far from the scientific method, relying on inference rather than direct evidence. Others counter that the multiverse, though inaccessible, It's a natural consequence of theories already supported by observation. If inflation is real, eternal inflation may follow. If quantum mechanics holds, then many worlds may be unavoidable. The multiverse, in this view, is not an invention. It is a conclusion. Beyond the mathematics lies philosophy. The thought that reality is larger than the universe we see destabilizes the human sense of belonging. If other universes exist, then ours is not central, is not special. It is simply one possibility among countless others, no more unique than a single wave upon an infinite sea. And yet this possibility also carries a strange beauty. It suggests that reality is richer than we ever imagined, that creation is not a singular act, but an eternal process, blooming endlessly beyond every horizon. The multiverse, if it exists, is not a limit to wonder, but an expansion of it. The emotional weight of this idea is heavy. Infinity ceases to be distant. It presses close, reshaping how we think of existence itself. In such a vision, every law of physics, every structure of matter, every possible history plays out somewhere in the grander whole. Our universe is not everything. It is only ours. What does it mean, then, to live in one bubble among many? It means that our existence, while fragile and local, is also part of a greater tapestry. A tapestry too vast to see, but vast enough to contain every possibility. It means that the word universe must be reimagined, not as the total, but as one verse in a cosmic chorus. For humanity, this shift is profound. To realize that the universe itself may not be unique is to confront the final loss of centrality. First, Earth was displaced from the center of the cosmos. Then the Milky Way became one galaxy among trillions. Now, even the universe itself may be only one among many. Each revelation has been humbling. Each one has pushed humanity further from the imagined center of existence. And yet, paradoxically, each revelation has expanded the human spirit. For to ask these questions, to imagine such vastness, is itself extraordinary. The mind that can conceive of other universes is no less wondrous than the universes it imagines. The multiverse may never be proven. It may remain forever at the edge of thought, a hypothesis that cannot be touched. But its philosophical weight cannot be ignored. It forces humanity to ask what reality truly is. It forces us to reflect on the meaning of existence when existence itself is multiplied beyond measure. Beyond the horizon, the possibilities stretch without end. Its bubble may be a cosmos. Each cosmos may hold its own story. And within one of them, ours life has risen to wonder if others exist. That act of wonder is not small. It is vast. For in the end, the multiverse is not only a question about physics, it is a mirror held up to human curiosity. It reveals not what we know, but what we dare to imagine, and in that daring, our universe finds its place in a reality far greater than itself. At the end of the 20th century, astronomers believed they understood the destiny of the cosmos. The universe was expanding, carried outward by the momentum of the Big Bang. Gravity, the great sculptor of structure, pulled galaxies toward one another. The question seemed simple. Would gravity prove strong enough to slow the expansion, perhaps even reverse it into collapse? Or would the universe expand forever, gradually coasting toward emptiness? The answer arrived not from theory, but from light. Two teams of astronomers set out in the 1990s to measure the expansion rate of the universe. Using type Ia supernova stellar explosions so bright they outshone entire galaxies. These cosmic beacons, with their consistent brilliance, served as mile markers across billions of light years. By comparing how bright they appeared to how far away they should be, astronomers could chart the history of expansion itself. What they discovered was shocking. The distant supernova were dimmer than expected. The galaxies hosting them were not slowing down under gravity's pull. They were speeding up. The expansion of the universe was accelerating. This revelation overturned centuries of assumptions. A mysterious force, previously unknown, was driving space to stretch faster with time. Physicists named it dark energy not because they understood it, because it lay in shadow, unseen, inferred only through its effect. Today, dark energy accounts for nearly 70% of the universe. It is not matter. It is not radiation. It is something woven into the fabric of space-time itself. The discovery of acceleration reframed the fate of the cosmos. Instead of slowing into stillness, the universe is rushing toward greater separation. Galaxies not bound to us by gravity will slip away, carried beyond the cosmic horizon, their light stretched into invisibility. The night sky, once crowded with countless galaxies, will empty. Hundreds of billions of years from now, only the faint glow of our local group Milky Way, merged with Andromeda and its satellites, will remain visible. The rest of the universe will be gone, not in destruction, but in distance, receding faster. Then light can bring their images to us. This future is almost unthinkable. A cosmos that once revealed itself in abundance will fade into silence. Astronomers of the far future, living on Earth or whatever worlds remain, will gaze into a sky stripped of evidence.
Ow.
The cosmic microwave background will have stretched beyond detectability. The expansion will erase the signatures of origins. For them, the universe will appear static and small. Only by some preservation of ancient records could they guess the truth that they inhabit a universe once seen to be vast. An accelerating dark energy thus shapes not only the fate of matter, but the fate of knowledge. It ensures that the story we glimpse today is privileged, a moment in cosmic time when the universe is both knowable and bright. We live at a boundary between ignorance and forgetfulness, able to measure the cosmos in ways that future generations cannot. In this sense, humanity is cosmologically fortunate. It was born into a universe that still reveals its scale. But what is dark energy? The question remains unanswered. Some physicists suspect it is a property of empty space itself, a cosmological constant, first proposed by Einstein and later abandoned. In this view, even vacuum carries energy, and that energy pushes space apart. Others suggest it may be dynamic, an evolving field whose strength changes with time. Still others wonder if it reflects a flaw in our understanding of gravity on the largest scales. Each possibility carries profound implications. If dark energy is constant, the universe will expand forever, cooling into what cosmologists call the heat death, where all stars burn out and black holes evaporate into radiation. If it grows stronger, expansion could accelerate catastrophically, tearing galaxies, stars, and even atoms apart in a final big rip. If it weakens or reverses, the cosmos might one day slow again, perhaps collapsing into a new singularity. For now, the evidence leans toward constancy, yet the truth remains hidden, just beyond certainty. The emotional weight of this discovery cannot be ignored. Dark energy is not only a scientific puzzle, it is a reminder of how fragile our understanding is. At the very moment humanity believed it had charted the cosmos, the universe revealed that most of its content is unknown. Dark energy and dark matter together make up 95% of everything.
No.
All the stars, planets, and visible galaxies amount to only 5%. Cosmos is not what it seems. It is structured and guided by shadows we cannot touch, and yet this ignorance is not defeat. It is invitation. To recognize the accelerating expansion is to realize that the universe is still unfolding, still surprising, still capable of revelations as transformative as Galileo's telescope or Hubble's galaxies. The cosmos resists closure. Every time we believe we approach final answers, it expands into deeper questions. Dark energy transforms the universe into a living metaphor. It stretches not only space, but imagination. It forces us to see the cosmos not as a static whole, but as a dynamic, restless entity, evolving and moving toward futures both wondrous and bleak. In poetic terms, the universe is stretching itself into isolation. Galaxies drift away like lanterns. Carried beyond sight, the fabric of existence grows thinner, quieter, colder. One day, only the memory of this abundance will remain, recorded in the fossil light of ancient stars. And yet, even in this vision of fading, there is beauty. The universe is not collapsing into violence. but expanding into silence. It is not ending in chaos, but drifting towards stillness. To imagine the cosmos dissolving into emptiness is to confront the fragility of all things, but also their transience, their fleeting brilliance before the quiet. Humanity, standing in this moment of clarity, is witness to a rare chapter. It sees a universe expanding, accelerating, vanishing into horizons that future eyes may never glimpse. This is both humbling and profound. For to see the fading is itself a gift of timing, a chance to know before the silence descends. Dark energy is a mystery that defines the universe's destiny. It is the invisible hand that pulls galaxies apart, the silent force shaping the future. It reminds us that the universe does not promise permanence. It promises change, and in that change lies the ultimate paradox. The cosmos expands into isolation, but in doing so, it draws humanity closer to the truth of its own fragility. For in the face of a fading universe, the act of wonder becomes all the more urgent. To see, to question, to imagine, these are the ways in which humanity resists the silence. The universe stretches, galaxies drift away, the future darkens. But in the present moment, beneath the night sky, the accelerating cosmos still glows with meaning, and in that glow, the expanding unknown becomes not only a horizon of loss, but a horizon of awe. The universe does not give up its secrets easily. Its earliest moments are hidden in darkness, its most distant realms veiled by horizons of time and light. Yet humanity is relentless. From glass lenses to mountaintop mirrors, from orbiting observatories to underground detectors, it has built tools designed not merely to see farther, but to touch the very edge of the knowable. The latest of these instruments is the James Webb Space Telescope, a golden eye suspended 1,000,000 miles from Earth, its mirrors, honeycombed and gleaming, open wide to gather the faintest whispers of infrared light. Unlike Hubble, which peered into the visible cosmos, Webb sees in wavelengths stretched by expansion. The ancient glow of galaxies born only a few 100,000,000 years after the Big Bang. To look through Webb is to travel backward across most of cosmic history toward the first stars, the first clusters. The scaffolding of structure itself, in those faint galaxies, lies more than beauty. They carry answers to questions that define the scope of the universe. How did the first stars ignite in a sea of hydrogen and helium? How quickly did galaxies assemble into the cosmic web we see today? And might their distribution reveal hints about the geometry and expansion of space on the grandest scales? Each photon Webb collects is a fragment of an ancient script, a message written when the universe was young. Yet even Webb cannot pierce to the very beginning. The earliest light visible is not starlight at all, but the cosmic microwave background. This faint afterglow, discovered accidentally by Arno Penzias and Robert Wilson in 1965, is the oldest light we will ever see. It was released when the universe was only 380,000 years old, when atoms first formed and the cosmos became transparent. Beyond it lies an opaque wall, where plasma trapped light in endless scattering. The microwave background is a cosmic photograph, a frozen imprint of density ripples that would later grow into galaxies. To study it is to hold in hand the first page of the universe's visible history. But light is not the only messenger. New tools are emerging that transcend the limits of photons. Neutrino astronomy is one. These ghostly particles, born in nuclear reactions within stars and supernova, stream through matter almost without resistance. Trillions pass through every human each second, unnoticed. To detect them requires vast underground detectors, tanks of pure water or ice shielded from interference. When neutrinos strike, they leave faint traces of light. These traces carry stories from the heart of exploding stars, and perhaps from the earliest moments of the cosmos itself. Another frontier is gravitational wave astronomy. In 2015, the Laser Interferometer Gravitational Wave Observatory detected the tremor of space itself, ripples generated by colliding black holes more than 1 billion light-years away. These waves are not light. They are distortions in space-time, carrying information from realms opaque to photons. In principle, Gravitational waves could carry echoes from the first fractions of a second after the Big Bang, when inflation roared and space swelled. If detected, such signals would provide direct evidence of the universe's earliest expansion, probing scales unreachable by any telescope. Together, neutrinos and gravitational waves form a new language of observation. For centuries, humanity listened to the cosmos in light alone. Now it begins to hear its vibrations, its faint shivers, its hidden voices. The universe becomes not only something seen, but something felt. Future missions aim to push the horizon even farther. Proposed space telescopes dwarf Webb in ambition. A Nancy Grace Roman Space Telescope, with its wide field of view, will survey billions of galaxies, mapping the structure of cosmic expansion with unprecedented precision. Other designs, like the concept of lavoir or habix, imagine mirrors tens of meters across, capable of directly imaging Earth-like planets around distant stars while simultaneously probing the faintest galaxies at the edge of time. On the ground, colliders such as the Large Hadron Collider at CERN probe the physics of the very small to unlock the secrets of the very large. By smashing particles together, scientists hope to recreate conditions of the early universe, testing theories of dark matter, extra dimensions, and perhaps even the mechanisms behind inflation itself. What happens in the smallest scales may reveal the architecture of the largest. Even more audacious are proposals for interstellar probes. Spacecraft driven by solar sails or directed energy, capable of reaching other stars within a human lifetime, though their goal may be to study exoplanets. The technology to send instruments across light years could one day enable missions designed to measure cosmic expansion directly from other vantage points, triangulating the structure of the universe. From multiple shores, each of these tools is more than an instrument. Each is a mirror of human determination, proof that curiosity does not yield to scale. The cosmos may be vast beyond measure, but the mind seeks to measure it still, and yet there are limits no tool will ever cross. The cosmic horizon is real. Light older than 13.8 billion years cannot be seen. Signals buried before transparency may never be recovered. Beyond the observable universe lies a realm forever beyond reach. No telescope, no detector, no collider can pierce it. The universe keeps its oldest secrets, but perhaps that is the point. The purpose of these tools is not to answer every question, but to deepen the mystery with clarity. Webb does not end wonder by revealing early galaxies. It multiplies it, showing structures too massive too soon, forcing theory to catch up. Gravitational waves do not end curiosity by confirming Einstein's predictions. They spark new questions about what might be heard next. Every discovery is an opening, not a closure. The emotional weight of these instruments lies not only in what they reveal, but in what they represent. They are symbols of a species that refuses to accept darkness. Fragile machines, built of glass and silicon, launched on pillars of fire, floating in silence, listening to whispers from across eternity. They are proof that small beings bound to one planet can stretch their vision to the edge of time itself. Standing at the dawn of this new age of astronomy, humanity occupies a rare vantage. It holds in its grasp the first light of the universe. The faint echoes of gravitational waves, the promise of deeper probes and wider mirrors. The cosmos will not yield everything, but it will yield enough to keep the story alive. The universe is vast. It is older, larger, and stranger than myth ever dared. Yet with each tool, with each observation, with each fragile attempt to listen, humanity pushes back the veil. The edge of knowledge is not a wall. It is a horizon. And every horizon once reached reveals another beyond. In this way, the scientific tools of today and tomorrow do more than map the cosmos. They reveal the shape of human curiosity itself, always reaching, always questioning, always daring to seek what lies just beyond the edge. The universe is vast beyond comprehension. It stretches across horizons that recede faster than light can carry their story to us. It expands into darkness, shaped by forces we do not yet understand, haunted by mysteries that may never yield to reason. And yet, against this immensity, stands a fragile species on a small planet. Daring to measure what may be unmeasurable, human beings are fleeting. Their lives last scarcely longer than the flicker of a star compared to cosmic time. Civilizations rise and fall in the blink of galactic history. Entire epochs pass, while the light of a distant galaxy makes its way across space, only to meet eyes that may not exist by the time it arrives. To place human life against the scale of the cosmos is to confront the fragility of all things, and still humanity measures. It builds telescopes that drink the light of the first galaxies. It launches satellites that listen to the echoes of creation. It digs deep into the earth to catch the faintest tremors of neutrinos, the whisper of gravitational waves. These tools are fragile, like the hands that built them. They are vulnerable to failure, to accident, to time. Yet together, they reach across billions of years. Pulling knowledge from the abyss, this act of measurement is not merely technical, it is emotional. It is the paradox of finite beings daring to question infinity. Human minds evolved to track the passing of seasons, to read the stars as guides for planting and navigation. Yet those same minds now ask what lies beyond horizons of space and time. What shaped the first moments of existence? What fate awaits in the dark expansion? Questions themselves are staggering. They are proof that curiosity is not bound by survival. It is bound by wonder. Science reveals the immensity of what we do not know. Dark matter, invisible yet dominant. Dark energy, pulling the universe apart. Inflation, hinting at realms beyond our sight. The multiverse, suggesting that even the word universe may be too small. Each discovery removes us further from the center, yet each also enlarges the scale of imagination. Humanity is small, but its questions are large. In those questions lies greatness. The emotional paradox deepens. The more the cosmos reveals, the more human fragility is exposed. Life exists for only a moment in cosmic time, suspended between birth and extinction. Stars live longer. Galaxies endure longer still. Even black holes, evaporating over unimaginable spans, will outlast every life and every memory. Against this backdrop, human striving seems insignificant. Yet perhaps insignificance is the wrong measure, for significance is not in size, but in awareness. The universe may stretch beyond all horizons, yet it is through human perception that it becomes known at all. The cosmos, indifferent and immense, becomes a story only when beings within it begin to ask. The act of wonder transforms isolation into meaning. The act of curiosity reshapes silence into dialogue. In this way, fragile creatures participate in infinity, not by matching its scale, but by daring to gaze into it. Philosophers once feared infinity as a concept too terrifying to embrace. Now it is a physical reality written into equations, measured in the light of galaxies and the geometry of space. Infinity is no longer distant speculation. It is the stage on which all existence plays. And into that stage, humanity steps, carrying questions older than language, older than culture, older than civilization itself. Life on Earth is brief. A human heartbeat lasts less than a second. A life lasts less than a century. A civilization lasts less than 10,000 years. But the cosmos spans billions. Against it, human time is nothing. Yet in another sense, it is everything. For in the space of a single heartbeat, consciousness can imagine the entire sweep of creation. In the span of a short life, a person can learn of galaxies, black holes, expansion, and horizons. In the brief flame of civilization, species can build machines that see almost to the beginning. A single heartbeat inside an endless night. That is the human condition against infinity. It's fragile, finite, but luminous in its daring. The final truth is that the universe will not bend to human needs. It will continue to expand, to evolve, to fade. Galaxies will recede, stars will die, matter itself may dissolve. The cosmos does not promise permanence. It promises only change. Yet within this vast and shifting expanse, Human beings carve out, meaning they write equations, they tell stories, they look upward and whisper questions into the dark, and in doing so, they become more than fragile. They become part of the mystery itself. For though the universe may never be fully measured, though infinity may never be fully grasped, the attempt is itself a triumph. The story of humanity against infinity is not one of defeat, it is one of awe. Fragile beings, small as dust, daring to measure the immeasurable, daring to imagine the unimaginable. Each heartbeat becomes an act of defiance against silence, an affirmation that even in the face of endless night, awareness burns bright. The cosmos stretches into horizons we will never cross. Yet in the short span of human life, in the fragile flicker of consciousness, the universe knows itself, and that is enough to turn fragility into greatness. The journey began with a question as ancient as starlight. How big is the universe? It is a question that seems simple, yet it unravels into infinities. Each age of humanity has asked it in its own way. Each answer has grown larger, stranger, more unsettling than the one before. Still the mystery endures. The possible answers are stark, yet each resists comprehension. Perhaps the universe is finite, a closed hole curving back upon itself. Immense but bounded, like a sphere too vast for any traveler to circumnavigate. Perhaps it is infinite, stretching without end, containing uncountable galaxies, stars, and possibilities. Or perhaps even these visions are too small. Perhaps our cosmos is only one among many, a single bubble in a multiverse where laws of nature themselves differ from one universe to another. Whatever the answer, it lies beyond human grasp. The observable horizon reaches 46 billion light-years, yet beyond it stretches a darkness no instrument will ever reveal. Infinity, if it exists, cannot be mapped. The multiverse, if it exists, cannot be tested. The cosmos, in its full immensity, will forever exceed the reach of fragile beings who live and die in the blink of cosmic time. This realization is not despair, it is humility. Every discovery humanity has made, the shape of galaxies, the expansion of space, the afterglow of the Big Bang, has revealed not only answers, but new frontiers of ignorance. Knowledge expands, but so does the shore of the unknown. The ocean of mystery does not shrink, it grows. And on that ocean's edge, humanity stands in wonder. Perhaps that is the truest meaning of the question. To ask how big is the universe is not to expect a final number or a neat boundary. It is to embrace the paradox that the more we know, the more immense the mystery becomes. It is to recognize that the human mind, though finite, is capable of stretching toward the infinite. In this light, the search itself becomes the answer. The act of wondering, of building telescopes, of writing equations, of staring into the night sky with awe, this binds humanity to the stars. Fragile lives are given meaning not because they master infinity, but because they dare to approach it. The emotional metaphor is simple, yet profound. Imagine children on a beach, drawing a circle in the sand. To them, it feels vast, complete. A world enclosed within a boundary, yet beyond that fragile circle lies the entire ocean, stretching into horizons they cannot see. Humanity is like those children. It has drawn a circle of knowledge, immense compared to the past, yet still only a fragile sketch against an endless sea. The true ocean of existence stretches beyond sight, beyond thought, beyond even imagination. And yet, the drawing matters. It is a sign of curiosity, of wonder, of the desire to understand. Each circle expands as knowledge grows. Each discovery widens the line between the known and the unknown. And though the ocean remains, the act of drawing binds the children to the shore. Just as the act of seeking binds humanity to the universe, the final truth may be that the cosmos will never reveal its true size. It may remain forever hidden, its boundaries undefined, its extent unknowable. But the mystery is not failure, it is invitation. The universe asks not to be conquered, but to be wondered at. Not to be measured fully, but to be pursued endlessly. In the end, the question of size is not about the cosmos. It is about humanity itself. To ask how big the universe is is to reveal how vast the human spirit can be. Small creatures on a pale planet daring to reach into infinity. The night sky does not answer. It glows in silence. And in that silence, humanity continues to seek. The universe may never yield its full truth. But the act of seeking this fragile, infinite yearnings, itself the bridge that binds humanity to the stars. And so, as the story closes, not with certainty, but with wonder. The universe is vast. Humanity is small. Yet in the act of asking, the two are joined forever.